A warm greeting to everyone. I am Selvi, Assistant Professor, CSE Department, RMD Engineering College. Now we are going to see about Queue data structure. In nonlinear data structures, it's the way of organizing the data in the memory. And now we are going to see Queue data structure. Here it follows the principle of first in, first out. That is the first item which you're going to add in the queue will be the first item will be come out of the queue. So we compare it with our real-time queue. So the first person who is in the queue will get the, you take for a ticket counter queue. The first person who is standing in the queue will get the ticket. The last person will be standing in the queue will get the last ticket. So if I'm going to add, first I'm going to add A, B, and then C, and then the output will be first will be A, B, and then C. Now we are going to see an example of a first in, first out queue. So a queue contains an integer elements. So you have two types of functions, NQ and DQ. So NQ will represent a insertion function. So using NQ, you can able to add an element into the queue. Using DQ, you can able to remove an element from the queue. So each queue has two parts, front end and rear end. So insertion will be done at the front end and deletion will be done at the rear end. Your create function is used to create a new queue, and isEmpty function is used to check whether the queue is empty or not, and size function is used to return the total number of elements in the queue. So the queue data structure comprises of the functions enqueue, dequeue, create, isEmpty, size. Now we are going to see linked list implementation of a queue. Created a linked list to which items would be added to one end and deletion will be done at the other end. So you have two pointers will be maintained. Front. So this pointer is going to point to the front element or the beginning of the in the list. And then rear. So deletion will be done at the front end. The rear another pointer pointing to the end of the list. So in queue, you have two element variables or pointers pointing to the location front and back end. So in front end, you will be having the insertion. So sorry, in front end, will be having the deletion. The rear end will having the insertion. Suppose if in NQ operation means I'm going to add an element into the queue. So already I am having 1, 2, 3, 4, 5 elements in the queue. I'm going to add the sixth element, which will be added at the end. So the sixth element, now I'm giving the next pointer of the rear end will be pointing to the new element. So from here, the connection should point to the rear end, and the rear end name will be changed to the new element. So now this will be your rear. Next, we are going for a DQ operation. DQ operation, so that means you're going to delete the element, front element. So this element should be deleted. So this element should be deleted means front will be pointed to the next element and the connection will be cut. Now we are going to see how we are implementing queue using linked list. First, we created a node structure. Here I'm using character variable. So character name and then next pointer pointing to the next node in the list. And also I have two pointers, front and queue, pointing to the front and the back end. So now if you see the NQ operation, you have a temporary variable and I'm going to add the, allocate a memory using malloc function. If temporary is equal to null means that means I didn't allocate any memory. I'll change the color. If temp equal to null means I didn't allocate any memory. Else I will be copying the value, which is I'm going to pass as parameter. So this character X is the value I'm going to pass it here. Okay, so that will be copied to temporary name. Now temporary will be having the value X. And then temporary next will be null. Now I've created an new node. Now I have to add this new node to the last item in the list, like a last item in the list. So moving to the last one, I'm just checking the Q real value as null, because the last item will be holding the next pointer value will be until that using this if condition and moving to the next pointer. If I'm reach the last value, I will be moving the Q's rear end to the next to the temporary. That is, I'm pointing the rear will now point to the new node. Now we are going to see the DQ operation. First, we'll be checking whether the front value is null or not. That is to check whether the queue is empty or not. If queue is not empty, we have to copy the address value of the front value to X. We will be freeing the memory. That is, we will be copying the front node address to the temporary variable and then we will be freeing it, and the front now will point to the next node in the queue. So init function is used to create a new queue. The front and the rear both value will be null. Initially, while initializing a queue, the front and the rear both value will be null. If you are saying, when you are saying a queue as empty, if the front value is null means, or you can say it as a queue equal to null in general, then the queue is empty. This is the way, we can say like a menu-like structure we can implement in main function. We can give a prompt messages to do queue operations and queues and DQ operations. Thank you.